morning, everyone. So today I'll be talking about introduction about this experiment. First of all, is general background. The experiment, which conducted by metal sheet SAC305, is a lead-free alloy that contains 96.5 tin, 3% silver, and 0.5% of copper. For this experiment, we are here to investigate the properties of this metal sheet by employing various operations to attain our goals. We would like to examine the following objective. The first one is to figure out the crystallography of the metal sheet base material that is known. The second thing is to examine the thermal properties of an unknown metal sheet base material. The third one is to determine the coefficient of thermal expansion measurement. Next, we'll go to the method. First method was use X-ray diffraction to identify crystallography. Next was differential scanning calorimetry (DSC) to observe and calculate the thermal analysis of POP. Furthermore, use dialometer to develop the coefficient of thermal expansion measurement of metal sheet by examining the microstructure of material.
Hello, doctor. Now I'm going to present about the methodology of this experiment. First and foremost, X-ray diffraction, known as XRD. Its experiment details. Material. The X-ray diffraction scan range was 20 degrees Celsius to 90 degrees Celsius for an unknown metal sheet based on a material. And for its procedure, firstly we check the XRD machine calibration, and then we pick a solid sample and top loading of holder, applying a pressure and smear uniformly onto the glass slide, and then assuring a flat upper surface and pack into the sample container, and then mount the sample into the XRA machine and go to the controller in data scan. Under that controller, go to the scan line, and then use COK radiation in the 20 degrees Celsius until to 90 degrees Celsius, and the scanning rate was used 1 degree Celsius per minute. And then lastly, apply the high scope program and extract the analysis data. Experiment details. The altimeter can be used to test a wide range of material, especially for the metal. It is provide a measuring a variety of properties, including the linear expansion and coefficient of thermal expansions. For the procedure, firstly we prepare the sample of a metal sheet, and then set the two to go switch to the on position to start the cooling system, and open the tank wells and set the flow meter to maximum flow position to start the aggregate flow. And this is 190 millimeter per minute was assigned, and replace the red plate and insert the sample in the holder parallel to the push rod, and adjust the thermocouple and record the temperature of the sample at the free end of the push rod thermocouple, and close the system by sliding the furnace section over the sample holder, and finally extract and analyze the data. Lastly, for the DSC, it's an experimentators material, an unknown metal sheet based on material, instrument diffraction scanning calorimeter machine Q10 was used, and the oxygen free nitrogen gas was used as the purging gas. And for its procedure, the sample and the type of pen are prepared, and the weight of the sample was made sure not to be around 50 to 20 milligram. The sample is kept as thin as possible and cover as much of the bottom of the pan. The sample and the reference sample are being placed inside a curable, which is the place inside the measurement cell of the DSC system, along with the reference pen, which is normally empty. The nitrogen, which acts as an inert gas, is used to prevent oxidation or other unnecessary reaction. The test is run and the result can be obtained.
A very good day to Doctor. I'm Tanya Grace and I'll be presenting results and discussion for DSC. So, based on the graph, you can see that the sample have an endothermic heat flow. This heat flows out of the sample as a result of either heat capacity or endothermic process such as melting or glass transition. On this graph, we can see that the sample have undergone melting process whereby there's only one peak being observed at 219.41 degrees Celsius. The peak is showing a very large endothermic peak which represent the melting point, the melting temperature of the composite. Hence, it is concluded that the composite melts by absorbing heat at 219.41 degrees Celsius. We can also observe that the heat flow of the composite is high, which is at 614.7 joule per gram. It can be also seen that the peak is almost a straight line. Therefore, we can conclude that the sample is determined to be a pure substance. That's all from me. Thank you.
A good day to doctor. I am Divakran would like to present about the result of experiment XRD. The study of crystal structure is applied in X-ray diffractometer XRD analysis to identify the crystalline phases contained in a material and so give chemical composition information. This method is mostly employed with crystalline materials. The X-ray diffraction pattern of an unidentified metal sheet is shown in graph. Expert high-score software was used to analyze the XRD data. In comparison to pure tin metallic, copper tin and silver tin, XRD patterns are mainly matched to the sample based on phase identification. Based on graph, highest peak is observed at 20 to 45 degree in the copper tin composite, and also there was additional peak at 20 to 32 degree in the copper tin and silver tin. As a conclusion, we can say that the percentage phases of elements in metal sheet samples are being able to be identified by using XRD. The quantitative analysis of the treated and untreated metal sheet is also can be interpreted by conducting the XRD characterization method. It can be concluded that the composite undergoes endothermic reaction as it absorbs heat and went through melting process. It is shown from DSC curve that the sample can absorb more heat in a short amount of time before the sample melts, as it has a high heat flow rate. As the DSC graph peaks grow broader, the crystallization of the molecules became harder. As for the dilatometer testing, we were unable to perform this experiment since the dilatometer requirements were insufficient, which is that the minimum thickness for sample testing is 1 mm, but our sample thickness was only 0.6 mm. Because the insufficient requirements, we failed to run the dilatometer testing. Thank you.